These boards enable us to engage with customers on a level playing field. They showcase the capabilities of our products in real-world applications. Our boards deliver innovative solutions to meet current and future demands. And finally, our boards provide a foundation for customizing and streamlining development and design interfaces.
As a system architect at Infineon, it's important to feedback these requirements to our technology, packaging, and product teams to lead with innovation. Also to feedback specifications to our system engineering teams who develops the reference designs to showcase product merits like efficiency, density, and reliability in power supplies. Finally, our mission is to support our customers to win in this thriving application.
We evaluate several solutions for the application, comparing their merits while meeting the necessary requirements. Common decision points would be cost and efficiency. We analyze further the most promising solution. Here, the experience also helps to have a good feeling early in time of what may or may not work before going further down the road. We start the system design with analysis in several domains including circuit, magnetics, thermal simulations, mathematical models, mechanical modeling with as much detail as needed.
So within the team, we are performing thermal simulations during the design phase of a power supply in order to evaluate the PCB layout and then do any necessary changes on component placement or come up with additional cooling concepts. We perform EMI analysis on simulation level to evaluate potential converter topologies, transformer structures, as well as filter designs. The design of the high-frequency transformer is based on theoretical analysis on proper design of the planar windings with combination of magnetic simulations to extract essential parameters. Additionally, we validate phenomena like the skin and proximity effect, as well as eddy currents, all of which contribute to power losses. During the debugging phase, we usually isolate and evaluate the performance of critical peripherals and individual converters before moving on to the integrated system.
So, in order to try some more cooling concepts for the most critical components of the power supply, like for example the LLC planar transformer, a more detailed modeling is required and more thermal simulations are conducted, targeting the specific component. After the theoretical calculations of the transformer, a validation of the different configurations are conducted in terms of power losses and current distribution to evaluate which arrangement is the best one, and check if any adjustments are needed. After the evaluation of each converter block separately, the full PSU is assembled and the operation is evaluated in steady state, checking also and adjusting all the necessary parameters to meet the required transient response according to specifications.
The complexity of demo boards mandates precise documentation of technical and project-related structures. It is within the responsibility of the project manager to establish and implement this on both ends, starting with explosion drawings that serve also as assembly instructions at a later stage. The 3D models are also rendered and polished to be later found along the exclusive content package supplied for all demo boards. All items utilized in the modules of the demo boards need to be procured. Purchasing and keeping records of purchases and related lead times is also handled by the project manager.
At the same time that we design the power stage hardware, we develop control concepts and we create a firmware from the Infineon controllers. Digital control is a must for the kind of complex systems that we are building. Once we build the first prototype of the real hardware, we start the testing and debugging of the system. Here we learn the most, we acquire a lot of know-how, we find mistakes, we find problems, and we create fixes that we will implement in the next iteration of the prototype. When we build a second iteration of the prototype, we need again to verify and validate all the requirements from the specification. Normally, thanks to all the work and all the preparation we have done during the development process, this will likely be the final one, thanks to all the great analysis that we did in simulations and testing before.
Towards the end of the project, we prepare detailed and informative documentation to share the results internally as well as externally through publication of technical papers. We present a design guide of our proposed solution, and we also generate materials for internal trainings as well as customer engagement. Now, based on the measurements and the documentation, we have the responsibility to train the field application engineers and communicate to them all the necessary information, since they have to showcase to our customer the performance of our solution and guide them towards the right direction.
好，就是这是来看这个实际的 Infineon， 就是这个 demo 的 sample 啊，就是可以看一下关于就是 PSU 这种 PSU 可以的设计的一个方法，然后就像比如说这个风扇的位置，之前可能会比较有的是在比较头部的地方，然后现在看起来是可以设计在比较偏中间的地方，可能对热流的部分有一些帮助。那这对我们设计开发当然可以有一些新的启发。那在电源路径的部分的话，跟传统的CIPS 的架构不一样。那传统的 CIPS 的架构的话，它的 AC input 是做在尾端。那做成这样子的长条状是用在 Power Shelf 上的时候呢，它的 Inlet 跟 Outlet 都做在同一侧。那我相信在这样子的设计下呢，那是需要花蛮大的功夫在电源路径的规划上面，因为必须要跑到后面再跑到前面来，对。那至于另外一点的话，就是说在 Infineon 的 Energy Buffer 的设计上面的话，它可以针对一些外来的电源的突破或是突然的失效上面，能够有一些缓冲，那可以避免后端的负载因为这样子的电源失效而发生故障。
Our comprehensive and structured approach to solution development ensures that we deliver high-quality, efficient, and effective solutions that meet the needs of our customers and drive success for our organization.